ore deposit? Go ahead, what do you got?
Anywhere you can find a resource used for profit.
It's a profitable earth resource. Yep. Profitable in today's economy. Which is kind of weird because think of copper back in the 1980s. Copper was in high demand, right? And then pretty much overnight, copper went from being used in wires to being replaced by fiber optics. So one day, copper is an ore deposit.
Copper's not even used for pipe anymore.
No.
Plastic.
Now we use plastic, PVC. Yeah, so overnight, you know, you could walk to your mine one day and look at all this copper, look at all the profitable copper, and then the next day somebody comes along with an idea that makes it obsolete, nobody wants it, and it's like, well, it was an ore deposit yesterday, all that copper is still here today, and it's not an ore deposit today because there's no profit in it. So an ore deposit is something that's profitable. So it's driven solely by economics and world demand. Where do we find ore deposits? You know, that's one of the things geologists are sort of charged with doing. We go out, we look for these sort of atypical rocks that might contain high concentrations of elements that humans desire. We talked about all those different minerals that we use, clays and feldspars, olivine. Well, a lot of those minerals are actually created from cooling melted rock, igneous activity. So we need to look in places where there's been volcanic activity in the past. Convergent plate boundaries, divergent plate boundaries. And a lot of the minerals we talked about the other day kind of fall into this category. Feldspars that we use in high-tech ceramics, tourmalines, we use them as gemstones and in optics. Gold, use it for jewelry, high-tech electronics, we use it as a form of currency. We used to use it in medicine. People used to take gold injections. You ever heard of that? They used to use it to fight arthritis. You know, arthritis is where you have joints that become calcified and your joints don't move smoothly along one another. Well, if you inject gold, what they found is that the gold will accumulate in the joints and sort of smooth over the rough places that the arthritis has damaged. It also turned out to be toxic and didn't work real well, so they quit doing it. But that was only about 30 years ago that they started pioneering these gold injections. Again, they don't do that much anymore. Diamonds are a magmatic deposit from a certain type of volcano called a kimberlite. Lots of these in South Africa, but you can find kimberlites in Montana and Arkansas here in the US. There's been diamonds mined out of both of those states. Not very gem quality, but good for grinding and abrasives. So we look to areas that have in the past have had lots of volcanic activity. Old convergent plate boundaries, old divergent plate boundaries, current convergent boundaries, current divergent. Where are most of the current divergent plate boundaries, where plates are moving apart? In the oceans. Do we mine the oceans? Not really. We want to, but it's difficult. It's more expensive because all the technology needed. There is some ocean mining going on, but it's pretty limited. But there's 30,000 miles of mid-ocean rift that is all actively volcanic today. Do you think there's deposits of good stuff out there? Certainly. So when I said a couple class periods ago, we're not really running out of anything, it's really true. We're really not running out of anything. There's lots of stuff out in the oceans, but it's more expensive to mine out there, And there's a big resistance to mining the ocean. You know, if you mess up one part of the ocean, you really mess up the whole ocean because of the way ocean currents carry stuff around. So there's an awful lot of resistance to start large-scale ocean mining. Hydrothermal deposits are another type of famous ore deposit. Hydro meaning water, thermal meaning hot. So these are basically hot water deposits that contain dissolved minerals. So again, you need heat, and you would look to volcanic areas. So really, most ore deposits are found in old volcanic regions. How many of you have heard of the Cripple Creek mine? Yeah, it's down outside of Colorado Springs. Real famous gold deposit, still being actively mined today. They've taken, I heard the figure the other day, just a ridiculous amount of gold out of that deposit. Cripple Creek is basically a big old volcano. They're still mining it today. So the actual volcanic rock itself might be an ore deposit, or in this case, water flowing through cracks in the rock can leave behind some of their dissolved materials like gold, silver, copper, lead, platinum. So in both cases, we look for old volcanic. So we look for areas that have high heat flow. Old plate boundaries. In fact, most of the world's copper is found along recent or active subduction zones. If you go down to Arizona, there's several large copper mines down in Arizona. Arizona used to be on the coast, and it used to be a lot like California, Oregon, Washington is today. Areas where two plates were either sliding past one another or colliding with one another. And then we talked about divergent boundaries. There's 30 to 40,000 miles of ocean rifts that are beneath our oceans today. So there's a huge potential for ore formation in our oceans. And because of the potential adverse environmental effects that large-scale ocean mining could have, there's also huge resistance to mining. I had a friend back in grad school who was working on a research vessel off the coast of Washington, and they were just mapping the ocean floor, and they kept having their boat rammed and stuff thrown at them from the Greenpeace Rainbow Warrior ship that would go out there and harass them. Just the fact that the research they were doing could be used by mine prospectors was enough to draw the ire of some environmentalists. So there's a huge resistance to even thinking about mining the oceans today. But what happens as we add more people, we add more demand for resources, the prices start going up. There's going to be certainly more and more focus on looking to other areas to supply the products that we need. So you're going to hear more and more about ocean mining as our population grows and as we keep looking for resources for all these people. So again, as resources that are easily attainable start to get more scarce, we start looking for other alternatives, either other places that hold more of the resource or a different way to do things with other resources. Okay, any questions so far? All right, that's just kind of the background, the geology. Now I want to give you kind of the human part of this. We've talked a little about the use of resources, and it's probably even way more complicated than you think. You guys, most of you are writing. Some of you are using a pencil. Is there anything simpler than a pencil? Not really, right? That's one of the simplest tools we have. But even that requires a ridiculous amount of resources just to make that pencil. Pencil has an eraser, right? Anybody know where that eraser comes from? It's a petroleum product, something we mine out of the ground. What about that little brass, greenish, copperish thing that holds the eraser to the pencil? You mine it. It's made out of metal. Yeah, it's zinc and copper. Two different mines. What about the shape of the pencil? Do you have little hexagonal trees growing out in nature that you can simply pluck and make a pencil out of it? No, they're taking wood and they're using machinery to shape it. So you need iron and other metals to make the machinery to shape the pencil. What about the paint on the pencil? Actually, it takes about 3 different mines. It's all pigment that's mined out of the ground. How many mines are we up to now? Quite a few, right? But we're not done yet, because you need graphite and clay for the pencil lead. No lead in pencil lead, it's graphite and clay. A couple more mines. So you're looking at 8 to 10 mines just to make a stupid little pencil. What about that nice little MacBook there? Look at all the stuff. Look at all the stuff in this room. You know, we do have a lot of wood products in here that are grown, but we have a lot of stuff that isn't wood that must be mined. So I know a lot of people don't like mining. I'm not here to defend mining companies because they do. Some are very good, some are very dirty, but the fact is, to have the products that you want to make your life easier and better, you have to have mining. That's just straight up fact. Get rid of mining and then think about all the things just in this classroom that would go away if you didn't mine. Think about all the stuff that you use every day that would go away if you didn't mine. Mining is absolutely a necessity if we're going to have the kind of lifestyle we live. Now, it doesn't mean we can't do it cleaner. We can't use modern ideas to limit the impact that this has on people, plants, animals, but mining isn't going to go away. I've always said, you know, if you really want to do something for the environment, don't go protest a mine and hold up a sign. Be a scientist. Come up with ideas to do this stuff in a better manner that's better for everybody that relies on the surface of the earth to live. Let's look at the stuff we use in just in the US, okay? Remember, we only have 4% of the world's population. But we're going to take a look at how much stuff we use here in the US. I can tell you right now, you guys are a bunch of pigs. And so am I. We use a lot of stuff. So I have a little chart here. So we're going to have the resource, something like aluminum, gold, tin, iron, and then how much we produce here in the US. How much comes out of mining here? If we don't mine it here, where do we get it? We import it. So this will show us the difference between how much we use and how much we produce. If we consume more than we produce, that means we must get it from somewhere else. What's What are some issues with importing materials from other countries?
Sometimes we have embargoes, so we can't.
So it can be costly to us. What else? All that damage is somewhere else, right? But what about your money? Where's your money going?
To them.
To them. Think about oil. You know, we have a booming oil industry here in the US, and it provides us with just a couple of % of what we actually use. So where do we get it from?
Middle East.
Yes, our biggest importer is from Canada. That's where we get most of our oil from. What they don't tell you though is that Canada imports oil from the Middle East and then sells it to us. So Canada produces quite a bit, but they also get a lot of Middle Eastern oil and give it to us. So a lot of it goes to the Middle East. How many countries in the Middle East are we on good friendly terms with?
Like two.
Like maybe 2. Even that's pretty tenuous. Do you want to send them your money?
No.
Because they can do bad things with that money, right? But what are you going to do at least once this week? You're going to fill up a tank full of gas. Most of that petroleum came from countries that
Hate us.
hate us. Is that what you want? And that's what you're doing. If we didn't do that, though, what would we have to do?
Well, do it here.
We'd have to do it here. What would happen to the price? Are you willing to do that?
No.
No. So you're kind of screwed, aren't you? These are not easy problems to solve. Problem is that we consume so much crap. Take a look at aluminum. I think I didn't put the numbers up, but this is in thousands of tons per year. It's a lot of stuff, right? We produce a lot of aluminum. What about our consumption though? It's higher, so that means we have to go elsewhere. A lot of that probably comes from China. China, South Africa, Brazil, big mining countries. Back in the 1980s, we used about 1/3 of the world's aluminum. 1/3 for a country that only has 4% of the world's population. It's down to 11% now. That's not because we're using less. It means that the rest of the world is consuming more. China has gone kind of crazy in its consumption. So is India. They want the same lifestyle that Westerners have. So they're buying stuff as fast as they can. Some of that requires aluminum. Copper. We used to use 1/4 of the world's copper. Again, we use about the same amount, but now everybody else is using so much more. So our percentage drops. But again, we produce some, but we consume even more. So we have to import it, mostly from, I think in this case, Mexico. Chromium. It's a minor element in some high-tech alloys. We don't produce any of it. We have to get it all from other countries. The story goes on. Lead. We use still about 1/3 of the world's lead. We use it in some high-tech applications. Gold is about the only thing we produce more than we consume. Lots of gold being produced in Alaska. Some minor amounts in Colorado, Nevada. Even something like salt. The big things to take away from this is that in just about every case, we consume more than we produce, and we consume more than our 4% of the world's population would dictate. So we are big consumers, and we're big importers, because we like stuff. We love stuff. We gotta have lots of stuff. I have a whole house full of stuff. I don't need all of it, but I buy it anyway. So these numbers are from 2012, where it says down from, those are numbers from 20 years earlier. And again, we didn't actually use less amounts of this stuff, maybe a little bit. The reason our numbers dropped is because China, India, South America, Southeast Asia, parts of Africa are all consuming more. So there's bigger and bigger demands on mining, because we're still consuming, and now everybody wants to consume at the same rate we do. These are in tons per year. And the US dropped. We are recycling more. We're up to about 40% of our aluminum now coming from recycled. But we don't recycle other elements nearly to this extent. But mostly it's because other countries are consuming more. So we have 7 billion people and they all want lots of stuff. And we can't grow all that stuff. So mining is a necessary activity for us to maintain this lifestyle. Any questions? Okay, so I'll let you go with this. We'll just give you some main points. We use a lot of stuff. We only have 4% of the world's population, and for most elements we consume between 5 and 40%. But other countries want to do what we're doing, so they're also using more and more resources. So not only do we have populations increasing, but we have developing countries that are becoming more and more mechanized. So the bottom line is that mining is going to be a big part of our future. There's going to be more and more pressure to get more materials for more goods. Now, some of this will be offset by our technological advances. We come up with ideas all the time for using less of this. So there's this constant battle today between increased population putting demands on resources, and that's counteracted by our ability to think our way out of some of these problems. It's like, okay, we can use less, or we don't need copper now for pipes and for wires. We can use another resource for that. So our ideas are constantly being pushed to their limits because of population increase. And so far, our ideas are winning out. If you look at wholesale prices for goods, they've been going down. We're getting better and better at getting stuff out of the ground, and we're getting better and better at using less of it to do what we need it to do. I don't know how long we can continue to stay ahead of it, but so far we're doing a good job. So that's the big question. And that's the question I can't answer for you. As time goes on, we'll start running low on some things. It'll get expensive, and people will come up with ideas for doing it a different way. But in order for that to happen, everything has to get more expensive. So you will see prices for certain things go up in your lifetime, and then we'll switch to something else. We're starting to see that with petroleum. I think we're going through a big transition right now where petroleum, was up around $4 a gallon for gas, and that caused people to change their behavior. And now we're looking to renewables. We're looking to hybrid cars. We're looking to electric cars. All right, any questions? We'll stop there and we'll start a new part of this next week. Oh,